Alright, welcome back. Today is your test review for Unit 9 for Pre-Calculus. So we'll start with number 1 here, where we are plotting polar coordinates on the polar grid. So let me just bump this up just a tad here. First issue, if you have a negative degree, you can add 360 to get positive equivalence there. And we can see our 4 answers now. So 5 to 80. For A, 3 to 10, which is going to be for B right here in quadrant 4. Negative 4, negative 120, so that's the same as going to 240. And if you go to 240 and then go backwards 4 here, C, and then negative 370, so same thing, we go to 70 degrees and go negative 3 to get to D. So if you got any questions on that, let me know. 70 right here should be, and then negative 3 for D. Alright, for 2 and 3, we've got r equals negative 5. That's the same as r equals positive 5. That's a circle of radius 5. And then theta equals 210. Go to 210 degrees. Make sure you put that line all the way through your grid. Okay, number 4 is our polar graph here. And what I would suggest here, roughly every 30. So when you see this, you can see this isn't every 10 degrees, and when you scale this out on your calculator, I'd go every 10 degrees on your calculator. But as far as a chart, every 30 degrees is fine. That's what I would do. You do not have to plot all of these points. I put more than are needed just to give you the detail of what's going on here so you can see this shape. But again, this is a cardioid. I put every 30 degrees, so you can see 4.5. That's a pretty simple one to get on there. 5.6, 6, 4.5, 1.5. So some points that you could plot relatively easily and get the definition of this shape. I'm not looking for you guys to draw perfect, picture perfect drawings here, but you do want to make sure you have enough detail you can clearly see what it is and that it is to scale. Alright, page 2. Here's your distance formula for polar coordinates. So if you don't have that, write it down. Make sure you have access to that. R1 and R2, that's going to be your R coordinates here. And then theta 2 and theta 1. So theta 2 is 70, theta 1 is 150. Plug those in accordingly. And we'll simplify here, roughly 3.46. This is in degrees here, so make sure you're in degree mode when you plug in your calculator. So I've seen a number of people do this correctly, but get the wrong answer because they have degrees here and then they're in radian mode. Later, you're going to have to switch back to radian mode, but for this problem, make sure you are in degree mode. All right, 3 other representations of the coordinate here. So we have 10, 300. So the first one will be the negative equivalent of this, which is 10, negative 60. Then we can go on the other side of the circle. So 180 degrees to the other side is 120, but then I've got to make r negative. So negative 10, 120. And then what I will do is I will take the negative equivalent of this, which is negative 240, and that r value stays negative. So again, all 3 of these are the same spot as this one. Make sure that your degrees here are between negative 360 and positive 360. All right, number 7, rectangular coordinates. So x is r cosine theta, y is r sine theta. Here's your r and theta. So negative 6 cosine of 150, negative 6 sine of 150. Again, because this is in degrees, make sure you're in degree mode. Here's my x and y. So my rectangular coordinates here, 5.2 and negative 3. Okay, number 8. Find the polar coordinates. And here's our rectangular coordinates. This is quadrant 2, by the way, right? Negative x, positive y, so that's quadrant 2. So that's going to come into play here. So first thing I'm going to do, I'm going to square both of those. That's going to give me my r value. So I square my x and y, get square root of 40. Then I'm going to take the inverse tangent to get my angle. When I do that on my calculator, I get negative 18.43. However, I'm in quadrant 2. Quadrant 2 is between 90 and 180, so I have to add 180 degrees to that to get 161.57. So please make a note right here of the adding to 180 and why we added 180, because we are in quadrant 2. Okay, number 9, write the polar equation in rectangular form. So first thing we're going to do here, multiply both sides by r. The reason we do that, by definition, r squared is x squared plus y squared. R sine theta is y. So here are the 3 equations that we asked you to memorize earlier in the chapter. R squared is x squared plus y squared. Y is r sine theta. X is r cosine theta. So we multiply both sides by r. Allows me to change this back to rectangular. You do not have to try to solve this for x or y. Just leave it right like that, and you're good. All right, page 3. This is very similar to what we did in the quiz the other day and on that quiz review. So we have this complex number. We need to write it in polar form. So we'll find r. Again, we square these. -3 squared, -8 squared. Remember, when you square a negative, you get positives. Square root of 73 is 8.54. Now again, here we need to be in radians, so make a note of that. Do inverse tangent on my calculator. And I get 69.44 degrees, but that has to be in radians. So whether you find it in degrees first and convert it, or just change this to radians to begin with, please make a note, if you change this to radians to begin with, then you're going to have to add pi, because you're going to get the wrong answer without adding this pi value here. So if you like degrees, that's fine. Get your final answer, then change it to radians. Pi over 180 will do that. Otherwise, you can put in radians right away and just remember to add 3.14. So now I have r, now I have theta, and I can write this r cis theta, and this complex number is now in polar form. Okay, 11 and 12, we're back to some complex numbers here with I. 231, you could divide that by 4 and you'll get a remainder of 3, or 0.75 when you divide. Another way you can do this, you can take a multiple of 4, so 228 is a multiple of 4. I know that every multiple of 4, if it's an I value, is 1. So this is the same as I to the third. I to the third is negative I. This one was not on the review. I just added this one, negative 38. If you have a negative, we take the next multiple of 4 that's smaller than that, so that would be negative 40 times I squared. Why? Because these two add up to negative 38. This is a multiple of 4, so that's 1. 1 times I squared. I squared is negative 1. All right, here we are foiling. I changed I to the 7th. That's the same as I cubed, so I substituted that out to negative I right away before I multiply it. So you can see right here, I change it to negative I, which is really plus I. So then 2 times 7 is 14. 2 times I is 2I. Now I can combine my like terms. Make sure the real number here is first. So 26 minus 13I. Do not put the I term first. All right, 13, again, we're just straight up foiling there. Let me slide this down a little bit. So 13, we foil. Remember, when you get I squared, that is negative 1. So negative 24 times negative 1 is really positive 24. Then combine our real numbers, so 27 plus 14I. When we have a fraction, you have to multiply by the conjugate. For the conjugate, you change the sign here of the I term in the denominator. So 1 plus 4I. We're going to FOIL. Again, simplify your I squared term. So this one's negative 8. This one's plus 16. Combine our like terms. And I get negative 2 plus 26I over 17. I cannot reduce this. 17 does not go into 26 or negative 2. There's no common factors there. So this is my reduced answer. Again, as always, if you need to, go back or hit pause as you're writing here, and that's fine. Okay, 15. We want to graph and label these. Very similar to the quiz again the other day. You square your A and B. Here we just have an A value, so that's 0. So that point's right there, no line. 8 squared plus negative 6 squared, that's 100. Square root of that is 10. So 8 negative 6, so there's our point. And then here Z is negative 5, so right out here, again, make your line from the origin to your point. All right, page 4, final page, home stretch. Okay, dot product. Remember with the dot product, you multiply the first two, multiply the second two, add them together. So our dot product, we get 50 and negative 50. Are they perpendicular? That's when you add them. Yes, they are, because they add up to 0. If it adds up to anything other than 0, then it's no. Right, here's a vector review problem. We got a boat sailing 35 miles per hour. 50 degrees south of due east. So due east is 0. So 50 degrees south of that is going to be 310. So you want to make a note of that here. That's at 310. And the wind is blowing 12 miles per hour, 20 degrees south of due west. So due west, that's at 180 degrees. 20 degrees south of that's going to be at 200. So again, you want to make sure that you have the right angles here. 50 degrees south of due east is 310. 20 degrees south of due west is 200. Okay, so again, now that we have our correct angles, we can plug it in for x and y. So again, we do our cosines first. So 35 cosine 310, 12 cosine of 200. It's 11.22. Do the same thing for our y's. So 35 sine of 310, 12 sine 200. We get a negative here, that's fine. We do our magnitude first, so we're going to square both of those and take the square root. So we find out that our boat is moving at 32.89 miles per hour. And then we'll do inverse tangent for the angle. Again, we're in degrees. Since our angles are in degrees, I got a negative 70.06. We'll add 360 to that because we want a positive equivalent, obviously. And so 289.94 will be the degrees. Okay, number 18. We got A and B, and again we want to find negative 2A plus 2B, so I'll multiply this one by negative 2, multiply this one here by 2, and I'm going to add those together, and here is my resultant. Very similar to the quiz again. 19, the magnitude, so we square all three of these, take the square root, 11.45, and then here we have our unit vector, I, j, and k, so negative 7i, 1j, 9k. And 20, write an equation in slope-intercept form given the parametrics. Solve each of these for t. So the first one, t equals x plus 8. Second one, t is y minus 2 divided by negative 3. Now I can set this up. I'm going to cross multiply. And after I do that, I solve for y. And here is my slope-intercept form equation. So I move the 2 over to negative 2 over to the other side. And there is, after I cross-multiplied, and that's my slope-intercept form equation. All right, so that's your test review. You guys should be all set for that. And again, as always, got any questions, hit me up on Google Hangouts or shoot me an email. Don't forget our live chat sessions this week, Tuesday, Wednesday, and Thursday at 11 o'clock. All right, thanks.